Hi, in this video I'm going to show you how to create a project with Vitis Unified IDE. We're first going to create our hardware design in Vivado 2024.1 with a hardware design that has a Zinc SoC in there, and then we're going to export that design, bring it into Vitis Unified IDE, and then create a simple Hello World application. Okay. So let's first start by creating a project. I'm going to put this inside of a folder that we can use to push to Git, which means that I have to create a subfolder. ho2 vitis. Okay, and then I'm also going to call my project the thing, and I'm going to create a project subdirectory which will contain all of the Vivado files. Next, then I'm going to choose the board, the pink Z2 in this case. Okay, and we create a project. Once this project is done, we can then create our block design. Name of the design you can choose. If you want to call it Zinc SoC or whatever is okay, but change the directory to a location outside of your Vivado project. So in this case, I'm going to make a new folder inside of this folder here. I'm going to call it BD for blog designs, and I'm going to store all my blog designs inside of that folder. Okay, let's call it Zinc. Okay. Then we need to add some IPs. So we're going to look for the Zinc processing system, add that one, and I'm also going to add immediately the processor system reset, which is needed to reset and initialize our Zinc processing system, and that will also be used to reset peripherals. Okay. Next, we want to run the run block automation. What is this going to do? It's going to set the default presets of our Zinc IP block, which are settings like memory chipset and clocks, etc. And this is based on the fact that it knows that we have selected in our settings the pink Z2 board, so it will make sure that all the settings, we'll have a look at those in a second, that all of those settings are correct. Then I'm also going to click on Run Connection Automation. This will connect our reset, so we select here all automations, and Vivado will for us create those connections. Then we click on Regenerate Layout, and then everything is organized a bit better. Okay. This is starting point which we need. If we double click on this IP block, then we will see the settings of our Zinc processing system. Okay, so this here is for our settings for our pink board, and as we can see, we have several IOs, SPI, I2C, and here you can also see which ones are enabled. Like UART0 is enabled at this point, that's the USB connection, and it's going to be sending data to our serial monitor, which we will run on our laptop, and the Hello World will be received through that UART0. So if you click on this UART0, you will see here that you can enable other settings here as well. For the moment being, we will not change any of these. If you click back here on Zinc Block Design, you will get back to the overview. For the rest, there's also clock generation. That will bring us to the clock configuration, which then shows you that we have a programmable logic fabric clock at 100 MHz, and you could also add 3 extra clocks if you wish. You could also change the clock speed up until 250 MHz for the PL. processor and memory are running at 650 and 525. So as you can see, you can find lots of information here in these settings. We will, in one of the later sessions, come back here and have a look at some other settings. For now, this is okay, and we will just accept these settings, save our block design, and once this is saved, we will generate the bitstream. So we don't need, at this moment, we don't need anything extra. Later on, we will learn how to add new settings. And as you can see, we still have a pin which is missing a connection, indeed. As you see here, this XI GPO clock needs a clock setting, and we can use our 100 megahertz clock like this. We save the design, and then we generate the bitstream. Okay. So this of course takes a while. It's not that long because at this moment we don't have much in our design. Top module is not set. Indeed, what have I forgotten? I have forgotten to create our output products, so generate output products and the wrapper. So always think about this, generate output products, generate. Okay, and after that you create your HDL wrapper. Let Vivado manage. And after this is updated, we see everything is generated now correctly. And now we really can start generating the bitstream. Okay, so this will take a minute. Running a sim design here at design runs. We can also have a look what's happening. And we see that it has already done some part, but still doing the synthesis. This moment, after that, it will start doing the implementation, as you know. So actually, it's going through all of these steps. If we click at the bottom at Generate Bitstream, you don't have to go clicking step by step through all of these settings. Maybe I can repeat that if you want in this view here to zoom into something, you can click and drag from top left to right. Zooming out is in the other direction. So just as something which you might have forgotten after a year of working with Vivado. Now it's running the route design. And as you can see, adding a zinc IP block does take some time, of course. Running write bitstream, and now write bitstream is complete. So in this case, we are not going to open Hardware Manager and program the bitstream as we did previous year, but we are instead going to export our hardware. And in the second screen, you say include the bitstream. So this is the bitstream of our design, and we're going to include this in our hardware platform. The hardware platform export is going to create an XSA file. As you can see here, the zinc wrapper XSA. The XSA is actually kind of a zip file that contains not only the bitstream, but also the board support package, which are header files and C code that you can use to program your Hello World application or even more advanced applications. So it contains drivers for UART, etc. Okay, finish. Okay, and now we have everything that we need. So if we go and have a look in the folder here, all our projects, then we see that inside of this folder, it has created zinc wrapper .xsa. Just for the fun, I'm going to show you that this is in fact a folder that contains C code. Now, as you can see, also the bit file is in there, hardware definition file, some other files that define the startup of our zinc processing unit. But it's just to show you that those files are in there. I'm going to delete again because we don't want to mess up our system. So we have the XSA file now. Then, from tools, we're going to start Vitis IDE. So this is the new unified IDE, as you can see. And once this has started, the first thing we need to do is create a new workspace. So I'm going to open a workspace. I'm going to go back to the folder where my project is, which is this one. And what I like to do is, instead of creating it just inside of this folder, I'm going to create next to our Vivado project a new folder called vitis, and I'm going to use this as my workspace. Okay, so open. Okay, so now Vitis has set up, we have a workspace, and we can start by creating our platform. So the platform is the definition of our hardware design. We create a new platform component. I'm going to call it pink Z2 Hello World, or maybe, yeah, let's just call it pink Z2, that's okay. There's nothing else in there, otherwise I might call it pink Z2 video encoder or whatever, but in this case it's a very simple hardware platform, so I'm just going to call it like that, and it's located in this Vitis folder, which is good. Next, I want to select a hardware design. So as you can see, we're going to have to select an XSA file, which we have created in our previous in Vivado. So I'm going to go to the folder where we can find this zinc wrapper XSA file. I'm going to open it. Then we can just click next. And now it's going to unzip this XSA, going to get all of the details out of there. And in a moment we see that we have the possibility to select an operating system. I'm going to choose standalone, but as you can see, you could also choose other options here, and then also a processor. And as you can see, we have two processors. As I told you in on this pink, we have two processors, two Cortex A9 processors, and we're just going to leave the default 0, but we could also put have the other processor running our Hello World application. Okay, generate boot artifacts, that's also good. And then a domain will be chosen, that's good, just next. So just keep all of the defaults. As you can see now, a script is running Lopper, which is a Python script that extracts data and starts building our project. Let me make this a bit bigger. And then we can see that here we have our pink Z2 platform. Okay. I can already build it. Okay, it's built, so this is okay. Now we have our platform, but we don't have our Hello World application yet, so we're going to choose from the examples here. If we scroll down, we will find Hello World. Here it is. And then I can create application component from template, and this will just create a basic Hello World application. So I'm going to leave it in the Vitis folder and call it Hello World. That's good. Then I need to select my platform, which is the one I have just selected. And also here the defaults are okay, so we're going to have it run on the Cortex A9 0, so the first processor. Okay, now it's creating this project for us, and as you can see, it's ready. and we could immediately start building it, but let's first go and have a look at the sources. Here you see there is hello world.c, and it's a very small application. It has 3 include files, which we will have a look at in a second. And then in the main, we have first of all init platform. That's going to configure our Zinc processor, and everything needs to be set up before we can start our application. And then we just print a hello world message and successfully run hello world application at the end. We clean up the platform, so that's also another function which we always need to call at the end, and we exit by returning 0. That's it. Okay, now we have 3 include files here. stdio, something you already know from C, just standard IO for doing the print. But we also have platform and xilprintf, and those are specific Xilinx libraries. The platform.h has been generated by Vivado. So as you can see here, there's some small things in there, but we can go to our PingZ platform, to sources, and inside this PS7, so for the ARM core, we will find include files, and one of them is x parameters. Here. This is a very interesting file. You will come back to this file to see certain addresses once we are using xi, which we will see very soon. You will need to have some of these constants here. So everything that is defined in your platform, as you can see here, the UART base address, you can find those addresses here. Well, you can just use the constant, of course, which is defined here. Don't change anything here because this is updated if you update your hardware design in Vivado. Okay, so that's one of the files that's certainly interesting to go and have a look at. We'll dig deeper in this later on, but as you can see, there's also libraries that have several other interesting files, like UARTs, timers, interrupt controller, and others that we will see later on to use. Okay, so I'm going to close this again. So now we're ready. We have our hello world. I'm going to select it, or you could also select it here, hello world, and we're going to build it. Build finished successfully. Okay. Next, there's one more thing you need to do. First, go to new feature preview under vitis, because you will probably have to enable your serial monitor, which if you click here, you can enable. Yeah? So make sure that you see it enabled. And once it is enabled, you will find under vitis serial monitor here. Yeah? If you click there, then you can select your USB port. Let me first get back to our example. I'm going to start a vitis serial monitor now on USB 1. Okay, it's listening, and I'm going to run our application. And if everything goes well, we should see a message here. And as you can see, we have hello world being printed over USB. UART is receiving this. Yeah. So the serial monitor that we had is USB 1 that you need to select, because USB 0 is being used to program the device. Yeah, this is our program. So everything's working, everything's okay. Let's say that you want to update your hardware design. Then you would first go here in Vivado, add some IP blocks, maybe change some settings. Again, make sure that everything here is correct. Your top is set, everything is generated again. You build your bit stream. Don't forget to export your hardware design to the XSA. Next, you go back here in vitis and to the settings of this project. Here, there you can switch XSA So inside of the settings of your project, the hardware platform, if you click on switch XSA, you can load your Zinc XSA file again, which will then be updated, and it will automatically start updating your platform. Of course, then you have to build it again, and also your Hello World application would need to be built again after that, because then it will pick up the changed platform, hardware platform again. Okay, so that's it for this demo. Try it. If you have questions, let me know. You should be able to get everything running like this. See you soon. Bye.